sigma, all pi, all sigma, all pi, or what?
2 2.
Mhm.
So these two will not be forming any type of bond.
Okay,
So
okay,
this one,
okay. Thank you very much.
this would be
Hmm.
2 into pi and 1 into sigma. 2 pi and
Hal,
1 sigma.
2 pi and 1 sigma. So see, nitrogen you see. So nitrogen, see, these already this s orbital you excluded. These are going to form the bond, na? So total
Yes, sir.
orbitals are how many are there? That is 3 orbital. So see, one orbital I am making this way. So this orbital, what I am making, that is going to be which orbital? This is the Z orbital. Yes or no?
Yes, sir.
This is Z orbital. They form the sigma bond. Got it. Now, how many orbital left if you talk about? That is Px and Py left. Px orbital, I am making this one Px orbital. Are you be able to understand?
Yes, sir.
This is Px orbital. Next one is going to be what is this is the Py orbital. So this is Px, this is the Py. Similarly, I am making this is Py. So this is Px and Py. So that is they are going to attract which one? X is going to form the bond with the X only. This one. They are overlapping
Yes.
side by side. Okay, this is the pi bond. Similarly, side by side overlapping takes place two places, not the one places, two places. Means above the plane and below the plane. This is the overlapping will be there. And then next one is there is going to be the pi bond. Oh, another one is YY overlapping. So this one, Y is going to overlap with the this one. And here is the Y is also going to overlap to this one. So this is the how many pi bond are there? Two pi bond and one sigma bond. Two pi bond and one sigma bond. Can't you understand?
Yes, sir. I
Oh,
understand.
okay. So this type of question generally they do not ask, but okay, for the concept building, it is quite good questions. Can we move on?
Yes, sir.
Okay. Now, if I will ask you, okay. So now after the valence bond theory, what you want? Valence bond theory, some more. Anything else is there? Hmm. This much is there in valence bond theory. No more information are there in the
The
valence
valence
bond.
bond theory is not coming this one, sir. MOT will be coming.
MOT will be coming. Directly you want to study the MOT. Should I tell the MOT? Should I tell the
Sir,
MOT?
I am not wanting, sir, you cover the syllabus as you want, but sir,
But
these things will be.
no. What is there? One point was there. Hybridization. Hybridization is not coming, na?
Hybridization is also hybridization is also coming.
Earlier you did not say that the MOT will coming. Hydro. So that is what. Let us see. Firstly, let me explain the hybridization. And VSEPR, VSEPR,
Yeah.
VSEPR coming or not?
Not coming, sir. Not coming.
Okay. Hybrid. Tell me what is the hybridization? Hello.
Hybridization, sir. So the two atomic orbitals they overlap to form a molecular orbital.
Good. So how it is defined? They define in the. I'm writing in the what the definition given. Two or more than two orbital. Two or more. Oh, sorry. Here they are saying two or more than two orbital. Two or more than two orbital having no Similar energy, similar energy, similar energy. Not the same, similar energy. Intermix together, intermix together, intermix together to form equal number of new orbital, equal number of new orbital, equal number of new orbital. They are going to form equal number of new orbital having similar shape, having similar shape and similar energy and similar energy, similar shape and similar energy, similar energy are called hybridization, are called hybridization. That is what hybridization. And formed formed orbitals are hybrid orbital. Formed orbitals are hybrid orbital. Hybrid. So concept this looking like the very large, but they are not like that. Okay. Can I erase? Can I erase?
No, no, sir, I'm writing. Actually.
Okay. The definition is a little bit lengthy. It is appearing, but it is very easy, very simple. Here is their different shape plus different energy. Not much different energy. What they are saying, intermix, they are going to be intermix. Intermixing is only called the hybridization. This is called hybridization. Okay. Then what is same number of new orbital. Orbital is same number. First point. Second point is if the same number of new orbital, same energy will be same energy level, same energy. Third, same shape. So these things are coming. It means this is the concept of hybridization. This is the concept of hybridization.
Yes.
So, can I reach?
Yes, sir.
Okay. Now, which bond you are expecting? Which bond you are expecting? Yes, this bond to be larger or this bond to be larger. Which bond you are going to expect? That is, both are the sigma only. Both are the sigma. Which bond you are going to expect that is larger, longer bond length?
Sir,
Which
the
one?
first one can be larger.
How?
Sir, because there can be more area of overlap.
Bond length is what? Distance between what? Internuclear distance, na?
Yes, sir.
Huh.
So the distance of the nucleus for that S1 will be less than that for the P1.
Okay. Which one is the larger? That I want to know. Which one is out of this second case? Which have the larger bond length?
Sir, larger bond length will be the second one, sir, and the smaller will be the first one.
Are you sure?
Yes, sir.
Okay. Now CH4. Let us see. Carbon 6. What is there? 1s2, 2s1, 2p3. I wrote excited directly. I wrote the excited state. 1. Excited state and ground state you must be knowing. Here. Total how many
Yes.
are there? This is s orbital. This is the px. And here is the py and pz. And okay. And what is about the hydrogen? 4 hydrogen are there. So they are having which orbital? S orbital, S orbital, S orbital, S orbital. So carbon. So here you see the carbon. So carbon one carbon is having what? S orbital, and hydrogen is what is this one? Okay. So this is the S bond S. Now SS overlapping. What happened? What happened to you?
Sir, nothing.
I thought you are rubbing your head, feeling
No, no, no,
pain.
sir. No, no.
I thought you are not understanding, so that you are rubbing the head. Okay, so I just want to explain the crux of the concept to go the further one. Okay, so this is what this is the P and P, right? No, no, no.
Yes.
Oh, wait. Sorry. Sometime I also did the mistake, because this is the p orbital and here is s, and this is the s, and this is the s. This is what? This is the orbital of hydrogen, upper one. This is the next one. This is the next one, and this is the next one. Here you see, if I will take the another color, this is the carbon. This is the carbon. Here is also going to be carbon, and this is also going to be carbon. Okay. Or all the bonds are same. See, this is sp, this is also sp, this is also sp, or all the bonds are same, or they are going to be different. That is what my question is. In methane, see how the bond is formed. Wait a moment. Carbon, here is the hydrogen, this is the hydrogen, this is the hydrogen, this is the hydrogen. But you go internally, this is formed by SS overlapping. This is P, S, this is the P, S, this is the P and S overlapping. Now, kindly explain that which bond is you are expecting to be larger bond length, and you go back the previous page also by keeping in mind what you said here. This one. You
Sir,
said
this one
SS.
I'm not understanding, sir.
What?
So this part I'm not understanding.
What to understand here? This part you understood or not? This one.
Sir, I understood that much. Is that is having the more bond length because they are.
Bond length. That is what bond length. PP is expected to be more, yes or no? Because the p orbital shape is dumbbell shape and s orbital is spherical shape. So when they overlap, they will overlap greater extent. Here overlapping will be the lengthwise extent is more. So here you come back this page. So carbon is having one s orbital is participating this one s orbital.
Yes, sir.
And rest of the p orbital.
Yes, sir.
And hydrogen is all are the s.
Yes.
So S you can say that it can be short. Yes or no?
Yes, sir.
And these three can be long. By the observation point of view, we can say like yes or no.
Yes, sir.
So and even s orbital is more closer to nucleus. S come first. See, the s orbital is coming first. So it must be the smaller size compared to the those coming the far. Yes or no?
Yes, sir.
Okay. But this is not observed. What the observation? All are same. All are same bond length. All are same bond length. To become same bond length, orbital side should be what? Same orbital. Yes or no? Orbital
Yes,
side will soon. Okay. So that is why all are same. So there occur intermixing of orbital. Understood? Intermixing of orbital. Sanoy Bhattacharya ji, understood?
Yes, sir.
मतलब ये क्या आ गया कि कॉन्सेप्ट ऑफ हाइब्रिडाइजेशन कॉन्सेप्ट आया, समझ में आया क्या? पहले हाइब्रिडाइजेशन का कॉन्सेप्ट इसीलिए आया कि ऐसे उन्होंने देखा स्ट्रक्चर ऐसे बना करके देखा बहुत सारे कंपाउंड में, तो उन्होंने क्या पाया कि दे वर एक्सपेक्टिंग टू बी द डिफरेंट बॉन्ड लेंथ बिकॉज डिफरेंट ऑर्बिटल डिफरेंट बॉन्ड लेंथ, but what they found that is they are all having the same bond length. So once the same bond length means the orbital size are also same. How can orbital size same? Because of the intermixing is possible. Now let us see the example. Suppose can I take the carbon itself? I am taking carbon. So carbon 6 ground configuration. Ground configuration means the not excited 1s2, 2s2 and 2p2.
Sir, can you bring the last page once again, sir? I want to note that down.
Okay, no problem. I will bring. See. अभी तो 10 10 बजे 10:30 तक चलेंगे 10:30 तक चलेंगे
Sir, done.
थैंक यू
Sir,
तो
another thing I forgot to tell you, sir, that one resonating structure is also coming, sir.
many things are coming when to cover resonating
Sir,
structure.
at least
See,
if you could give the basic introduction, then I can do the rest of the things.
basic resonating structure, I will make 10-minute video and I will share you for resonating structure and MOT. 10 minutes video I will make and I will share you, and next class we will cover that one also. Okay. For the because I'm also there only one Sunday I'm getting, and that Sunday is having huge work, huge work. Okay. Otherwise, if I will get time in the evening, I will connect with you if you are having. Otherwise, what you can do, I will make the video, short video, and I'll share with you. Okay, that will help you. Resonating structure is very easy, not that tough. MOT is also very easy, not that tough. Here you see, hybridization concept is quite okay, interesting one. That is, I am telling you. See, this is the ground state configuration, ground. So ground state means low energy, no excited. So here you will find what you are finding, that is 2 unpaired electron are there. What is the valency of carbon? Valency of carbon,
Sir,
Sanoy?
4.
4. Here, how many bond required, Sanoy? In CH4?
Sir, CH4, 4 bonds will be there.
So number of bond is equal to number of unpaired electron. Number of bond is equal to number of unpaired electron. Can't you understand? Number of bond is equal to number of unpaired. So in this case, it can only form the 2 bond. But what it is going to be, it is going to be the excited. When it is going to form the bond, it will go in the excited state. This is what is called excited state. Excited state. Okay. So it is going to be what the configuration 1s2, now 2s1, 2p3. So here what you are going to find? 1. Here is the what is there? 1, 1. So 4 unpaired electron there. Yes or no? Sanoy, can you tell me?
Yes, sir.
Do you know
4
what is
unpaired.
excited state? When the atoms going to combine, they will undergo the excitation.
Sir,
So
what is this excitation, sir? I do not have a very good knowledge on this one.
excitation means the electron get excited to enter into the higher energy orbital. Bohr's atomic model you study now. When electron absorb energy, get the energy from somewhere, it jump to
Sir, they
higher.
are going to the upper level of higher level of energy. But sir, how this one is changing the electronic configuration? Sir, like they are making the half
half filled. Both are going to be half filled now. Both are. S is also going to be half filled. P is also going to be half filled.
Okay.
Now you see the shape are the entirely different. S orbital and P orbital shape are different. So total how many orbital are there? Can you see those who are participating in the 4 orbital? So 4 orbitals. So one is the S orbital, and how many P? 3p orbital are there. No? So sp3 hybridization means that is, or you can say sp3 mixing. sp3 mixing, hybridization and mixing. So how many new orbital is going to form, Sanoy? That is equal number of new orbital is going to form. As many orbital participate, that many the bond is going to form. So total will be, and hybrid orbital is having the the larger lobes and smaller lobe. Hybrid orbital is having the larger lobes and smaller lobes. This is okay. Now total are there 4 orbital. Now 4 orbital. 4 new orbital. This is what 4 new orbital. FOUR 4 new orbital. Okay, they are having 4 new orbital. Got some 4 new orbital. These 4 new orbital will not exist individually. How they are going? They are going to reorient. They are going to orient themselves. So they are rearranging. Here they are rearranging. Rearranging. So that minimum repulsion takes place. So that minimize repulsion. Minimize repulsion. Repulsion. They are arranging. And how they are arranging? 109 degree, 109 degree and 28 minute means tetrahedral. See the structure here. How? This is the one orbital. Maximum arrangement. They will go maximum distance as possible. Second orbital. This is the back side of bond. Third. And next one is this one. So you must be having some little idea because you was already study in the school. So this is what the structure of the this is the structure of the sp3 hybrid orbital. So that is what tetrahedral shape of sp3 hybrid orbital. Hybrid orbital. Is it okay? Okay. Now these orbital, now see the hybrid orbital carbon in CH4 if you are making. So hybrid orbital you got to know this is the one orbital, another orbital, another orbital, another orbital. Okay. Then it is going to be hydrogen are also there. Now hydrogen is s orbital. So they are going to intermix here. Now these orbital are what is? Actual overlapping. Can you now you will be able to understand this one very easily. What type of overlapping is there here, Sanoe? This is sp3s. sp3 hybridization of this one. This is the sp3 hybrid orbital, yes or no? These orbital are sp3 hybrid orbital, and here is this or this overlapping is this overlapping actually this one, not this one, this one. This one is what? sp3s. This is what is this one? What is sp3s? And what is this one? This is again sp3s. So earlier we are saying that is what the hybridization we are thinking of overlapping sp. This type of overlapping do not exist. What the actual overlapping is sp3s, 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 sp3s. Understood?
Yes, sir.
Okay. So no, BeCl2 and another is there BeH2. BeH2. Suppose you go to beryllium. What is atomic number of beryllium? 4, I think. 1s2, 2s2, 2p0. In this case, can it form the bond? Any unpaired electron is there? Can it form? No, it cannot form. So beryllium is, this is the ground state. So beryllium will be given energy. Okay. So beryllium electron is going to be excited state. And this electron will be jumping here. Okay. So it will be 1s2, then 2s1 and 2p1. Now, how many unpaired electron can you find? That is there are.
Sir, how to know that which electron will jump where in this one, sir?
Which one will jump? Any one of this will jump because the hybridization is almost identical energy required. Na? S orbital cannot jump. No, this orbit is not possible. Here, 2 and 2 in the same quantum number, they can jump in the same quantum number. So where the paired one will jump to become the unpaired one, right? Because they have to, it needs to form 2 bond. Yes or no? 2 bond required.
Yes, sir.
2 bond formed. Yes or no?
Yes.
So 2 unpaired electron required. Can't you understand? 2 unpaired electron required. Not able to understand?
Yes, sir, understood. Do one pair, yes.
Hello?
Yes,
Not
sir, I
audible.
understood.
Not audible. Sanoe, not audible.
Sir, now audible.
You are not audible to me. Hello? Sanoe,
Sir, am I audible now?
not audible at all. Now, are you audible? No. Not audible.
Am I audible? Sir, am I audible now? Sir, I don't know, sir, what happened.
Oh, okay. What you be online. You be online. Let us explain this much at least. Okay. Okay. So here what is happening? This is the yes. Then you mute. Then you mute. Uh, from the because your audio is coming to me. It is reflecting back. What I am saying that same is coming back. Hello. So now it is going to over also. 2 minutes is left. That was we have to. So this is what 2 electron is required. Na 2 electron. Yeah. So 2 electron required. So that is 2 unpaired. So how we are going to make this one? See this one. We are making. So this is the s orbital. This is the p orbital. So 2 orbital are going to mix. Na 2 orbital. Yes or no?
Yes, sir.
2 orbital means one s is there, one p. So this is a sp hybridization. Sp hybridization. This is going to be sp hybridization. So sp hybridization means two new orbital will form because two are mixing. So two new orbital will form. So this is the two new orbital of the same shape and same size, everything. Now, what is going to happen here? It is going to, they are going to rearrange themselves so that minimize the repulsion. So only two are there. So how they can arrange? They can rearrange at 180 degree. So this is arranging like that. See, this is the arrangement of the two new orbital. So this is, and here is the 180 degree. So this is sp hybrid orbital. This is what sp hybrid orbital. Sp hybrid orbital. Are you be able to understand this one?
Yes.
Now you see the for BeCl2, chlorine is having which orbital unpaired electron? In which orbital unpaired electron is there in the chlorine? Any idea?
Sir, chlorine 17 watts.
PZ. Just we have done for nitrogen. Someone else we have done. PZ will be vacant. You check.
3P5.
Three. Okay. So here in the center, this is beryllium. And this side, what is it forming? Chlorine. But what type of overlapping is there? This is the sp and p. This is overlapping. What is sp hybridization? And it is p orbital of chlorine. Just now you are saying na p orbital of the chlorine, and this is what the sp, and this is sp. Can't you understand this?
Yes, sir, understood.
Okay. Make it.